Okay, I want to point out, reverse power rule, and then I write something down that's not correct, by the way. Let's put the correct version down, but I'm gonna have to cross this off and put the correct version down for you. So x to the n dx is gonna be equal to x. I increase the power by 1, not decrease it. Common error, by the way. And this is true provided n is not equal to -1. All right, so I'll correct that in the notes. All right, next thing up, let me multiply this out, and to do that, I'm looking for powers. So x to the 1/2 times x to the 1, well, 1/2 plus 1 is 3/2. And then you can get 4 x to the 1/2. I'm writing in powers for a reason, by the way. All right, I'm going to do the integration now. I can do that using the reverse power rule. I increase it by 1. So 3/2 increased by 1 is going to be 5/2. And then what do I notice? I notice that I'm going to have to divide by 5/2, but that's like multiplying by 2/5. Let's do the next one. That's going to be plus 4. I'm going to increase the exponent by 1, which would be 3/2. And I'm going to multiply by that reciprocal, which would be 2/3, plus some constant integration. All right, let me write this down for you, and I want to simplify it. 2x to the 5/2 over 5 plus 8x to the 3/2 over 3 plus c. All right, I'm going to get a common denominator of 15. This is still plus c over here. We'll look at the key later. And I'm going to, what times 5 will give you 15? 3, so it's 6. And let me make sure I'm saying this right, by the way. 3 times 5 is 15. 3 times 2 is 6. Well, 5 times 3 is 15, and 5 times 8 is 40. All right, I gotta simplify that. And I'm looking at that. I'm going to say 2. I'm going to say x to the 3/2. And what he left off with there. It's important to simplify, by the way. You may not agree with that, but I think it's important to simplify. What are you going to get? Well, you can get 3x. Let me make sure it gives you 5/2. Yeah, it gives you 5/2. And then plus 20. And I got that. All right, let's write this down. So I'm going to write it without the fractional exponents. Someone says, why is that? Look at the original problem. They did not use fractional exponents. So let's write this down. 2 root x. I'm sorry, I went too quickly there. It's going to be 2. 3/2 is 1.5, so it's x root x. And then you can get 3x plus 20 over 15 plus c. Put a box in that, look at the key, and I want to notice immediately in the key there's an error somewhere. Then I got the 2x root x over 15, I got the 3x, they got 5 and I have 20. So there's got to be an error somewhere. And I think I'm seeing it. Certainly, I'm agreeing with this. I'll put this over here. By the way, the key will be corrected. I'm seeing several errors already. And then I got this part over here. I do see that. But then I'm seeing I made a mistake in the antiderivative of 4x to the 1/2. And I'm going to check it for you. So the antiderivative of 4x to 1/2 is going to be 4. I increase the half by 1. That's going to be 3/2. You divide by 3/2. And what is this going to give you? 4x to the 3/2. Dividing by 3/2 like multiplying by 2/3. And what do you get up there? You get 8 x to the 3/2 over 3. So there's an error over here. I need to correct this. This will be correct. I'll correct. Errors come into this thing. I have several errors already to correct in this sheet. Thank you.